Good day, everyone. My name is Alec Warzen, and I'm a Senior Tech Advisor with the Renewable and Electrical Energy Division here at Natural Resources Canada. Today's session will cover the grid services requirements for the Smart Renewables and Electrification Pathways program that NRCan launched recently. Before getting started, I'd like to acknowledge that where I am today in Barrie, Ontario, is the traditional territory of the Anishinaabe people. I also acknowledge the Wendat Nation who occupied these lands prior to the middle of the 17th century. I'm also going to be joined today with Colton Pankhurst, who's another technical advisor, and he will speak later in the presentation. Before we begin, just a couple housekeeping items. Could you just take a quick look to make sure your feed is on mute during the presentation? You can definitely we can get you to speak later with a question if need be, but while we're presenting, if you could just check that you're on mute. We are taking questions at the end of today's presentation and look for a discussion if need be. So we're just asking if you can save your questions to the end, but feel free to use the Q&A box as we progress. We have some people behind the scenes monitoring that for us. We prefer not to use the chat box, but if you use that one by mistake, that's all good. We'll triage those questions and get to them at the end. And lastly, if you're calling in via telephone, which I don't think anyone is, but if you are, can you just let us know who you are with a quick email to our program inbox, just so that we can identify you better. And the email address will come up at the end of the presentation. So next slide, please, Emma. So today's section, as I said before, we'll focus on the grid services requirement of our program. We have a space for discussion at the end to make sure there's opportunity for everyone to share their experiences and to ask questions. We'll compile a list of frequently asked questions from today's discussion. The frequently asked questions will be available on our website in a few weeks. We're also recording this webinar, and as well, the recording will be made available at a later date. Next slide, please, Emma. The Government of Canada has set a target for Canada to become a net zero emitter by 2050. Canada already has a huge advantage to achieving this goal because our grid provides power that is both clean and affordable, with 82% of our generation coming from non-emitting sources. Despite this, electricity currently accounts for less than 20% of Canada's overall energy use across our economy. Becoming a net zero emitter by 2050 will require 3 decisive steps: expanding our clean electricity supply by replacing existing fossil fuel power generation with power generated from non-emitting sources, as well as adding additional capacity to meet demand growth. Secondly, use more clean power through electrification of energy use across key sectors of the economy. And last, using energy smarter by using energy efficient measures, technologies, and conservation. This also means that we need to use all of our electricity system assets more efficiently. This will require major infrastructure investments by all levels of government in order to build new non-emitting electricity capacity and to upgrade existing grid infrastructure. An affordable supply of clean and reliable power is essential to maintain Canada's competitiveness and our high quality of life. The federal government can play a role in mitigating the impacts of transforming the grid on ratepayers. The 2020 Fall Economic Statement presented Canada's vision for green economic recovery that is inclusive, sustainable, and creates good jobs for Canadians. In addition, the Healthy Environment and Healthy Economy Climate Plan, released in December 2020, has committed additional investments of $964 million over 4 years to advance smart renewable energy and grid modernization projects. This is the initiative we are speaking about today. Next slide, please. And this brings us to our program, the Smart Renewables and Electrification Pathways Program, or what we call SREPs. The objective of this program is to support the transition to a cleaner electricity grid and to create the foundational operational capabilities in our grid today to support the net zero economy of 2050. In addition, we recognize that underrepresentation of women, gender diverse, Indigenous peoples, and racialized people in the electricity and renewable energy sector, and how this has been further exacerbated by the COVID-19 pandemic. This program merges the importance of increasing clean energy generation capacity with the need to modernize our grids and the electricity system operations while supporting the increased equity, diversity, and inclusivity needed in this sector. The program meets these objectives in a 3-pronged approach. The program will support new energy generation coming online and ensuring it is able to provide the services grid operators need. utilities and system operators updating their software and hardware, and the creation of equity, diversity, and inclusion plans to increase equity in the electricity and renewable energy sectors. Next slide, please. Today's discussion is around grid services, which is a key pillar of the program, and projects must meet grid service requirements specified in the applicant guide. This workshop aims to ensure an understanding of the grid service requirements for different project types, provide familiarity with the grid service application template, and develop an understanding of required submission components to demonstrate grid service capabilities. Grid services are a key component of the Smart Renewables and Electrification Pathways program. Inclusion of grid service requirements aims to ensure that supported projects are providing value beyond energy to ensure a reliable electricity system as we transition to a net zero future. As the availability of grid service capabilities increases on the grid, utilities and system operators will have the opportunity to build familiarity with operating clean energy resources to provide a wider range of grid services. Now we will dive into a deeper explanation of our grid service requirements for the SREPS program. We'll be referring to section 5.2 and Appendix B in the applicant guide, and also attachment T5. You may want to have these handy as we continue through the presentation. And at this point, I would like to hand it over to Colton to continue further. Thank you.
Great, thanks for that, Alec. I guess we can go to the next slide. All right, great, thanks. So depending on the type and category of project within the program, grid service requirements may differ. Projects which include both generation or storage and grid modernization components, such as a microgrid, will be required to meet both categories. The intention of grid services for the established and emerging streams is to ensure supported projects are capable of providing grid services typically provided by synchronous generators. The focus of these requirements are on ensuring the control capabilities are present. We recognize that existing markets may still exclude provision of grid services from non-traditional resources and leave the final decision to use these capabilities to the utility or system operator. We will talk about which specific grid services are required and their performance requirements in the following slide. For grid modernization projects, both grid modernization projects led by utilities under the grid modernization stream, as well as grid modernization scope projects led by private entities under the emerging stream, will be required to meet those grid services specific to grid modernization projects. For these projects, we recognize that a wider range of services and values are provided to the grid through grid modernization activities. These projects must communicate how those services will be used in system operational processes to ensure that potential project services are actively used to benefit the grid. Next slide, thanks. So first, we will cover the established and emerging stream requirements. Grid services or essential reliability services include a variety of capabilities necessary to ensure reliable operation of the electric power system. Synchronous generators have typically provided these services, whereas non-traditional technologies have not necessarily been expected to do the same. As we increase the proportion of renewable resources on the grid, new technologies will need to contribute to services not previously required. For the purposes of the program, the minimum services required of all projects capable of delivering electric power to the system to satisfy section 5.2 of the applicant guide include fast frequency response or inertial response, primary frequency response, secondary frequency response or automatic generation control, and reactive power and voltage control. Specific technical requirements for each of these services are typically defined in applicable grid codes and connection requirements. We will discuss what actually being capable of providing a specific service means in a following slide, as well as discuss potential scenarios where existing requirements may exclude otherwise program eligible technologies. In the next slide, we will also introduce acceptable grid service reference alternatives where grid codes do not yet define these minimum services. We recognize that a number of other services and capabilities are valuable to the system, such as demand response, load shifting, and many others. These services can still be provided by our projects and are recognized as valuable. However, the fundamental control and monitoring requirements for the minimum services mentioned in this slide are required across all projects. Next slide, So as mentioned in the previous slide, all projects capable of delivering electricity, so typically generation and storage projects, must meet applicable grid code defined requirements for service provision of fast frequency response or inertial response, primary frequency response, secondary frequency response or automatic generation control, and reactive power and voltage control. Where these services are undefined in grid codes, transmission and subtransmission connected projects must refer to NERC reliability guidelines for bulk power system connected inverter-based resource performance. And that would be specific to primary frequency response, secondary frequency response, and reactive power and voltage control. And then in reference to the current standard IEEE 2800 for fast frequency response capabilities. Distribution connected projects may refer to IEEE 1547 2018 for capabilities to provide such services. We also understand that within these standards and in grid codes, service capabilities may be referred to as other names. For example, in some cases, primary frequency response is also called frequency droop control. Certification standards which confirm these capabilities, such as CSA standards, UL 1741, or others, are acceptable and recommended as supporting evidence to confirm these capabilities are available for a given technology when possible. We also recognize that fast frequency response is a relatively new grid service, and as a result, many grid codes do not yet have explicit requirements regarding performance or what specifically fast frequency response qualifies as. For this reason, where grid codes do not yet define fast frequency response, projects must demonstrate the capabilities to provide fast frequency response as defined in the referred standards. Fast frequency response has been demonstrated as an important resource to ensure reliability as inertia levels available on the system change according to the resource mix. This requirement aims to reduce reliance on conventional generators and demonstrate the value of this service from inverter-based resources. We also reserve the right to adjust fast frequency response performance requirements as IEEE 2800 goes through the finalization process towards final publication. So now we talk about what it means to be capable of providing a service. The capability to provide the minimum grid services means that projects must demonstrate they meet the grid code specified requirements for each grid service identified, or as defined in the alternative standards where undefined. We recognize that in some grid codes, specific grid service capabilities may not yet be required of certain project types. In this case, projects must demonstrate the capability to meet the applicable reference standards and guidelines. For example, primary frequency response may not be required of inverter-based resources in some grid codes. However, regardless, projects must have these capabilities as defined in reference standards identified. We recognize that certain operational limits may restrict program eligible technologies from providing the minimum grid services as currently defined in some grid codes. For example, some of these restrictions may include the maximum available active power, minimum active power, or resource availability for certain time durations. Projects are not required to have battery storage to meet these requirements or to operate below their maximum power capability unless required by the applicable utility. Incentives and pricing mechanisms for the actual provision of grid services remains the responsibility of utilities, system operators, and other regulatory bodies. The requirements of this program are to have the controls and monitoring capabilities necessary to provide these services while respecting any operational limits. We recognize that exceptions may be necessary from existing grid codes where specific requirements would otherwise restrict an eligible program technology class. These requirements might include things such as minimum size requirements or resource availability. These specific requirements may be identified and provided an exception. However, projects must meet all other requirements specific to each minimum grid service. For example, a grid code may specify that to provide a service, the available capacity must be 5 megawatts. As our program is able to support projects smaller than 5 megawatts, this specific requirement would be given an exception. However, all other requirements specific to that service would still need to be met. We also recognize the possibility of an exception for fast frequency response capability may be needed, where it is demonstrated that an eligible program technology is incapable of service requirements as an inherent limitation of that technology. A project will only be considered for an exception from fast frequency response where it is clearly demonstrated that this limitation is due to the technology or resource type as a whole, rather than the specific product or device chosen for the project. An example is the following. A specific wind product might not have the ability to use rotor inertia to provide fast frequency response. This project would not be provided an exception, and it would be expected to choose an alternative project which has the necessary control capabilities in place. Now that we've introduced these specific grid service requirements and what being capable means, we will introduce the grid service template process for established and emerging projects. A template is included with the full application package once a registration is complete and accepted. And Appendix B of the applicant guide describes suggested submission components to support eligibility assessment. The first step of the application is identifying specific requirements in the applicable grid codes and standards for the minimum grid services. It is important to ensure that the reference requirements are in line with those of synchronous generators and not reduce capabilities. For example, in some cases, a grid code may exclude certain service provision from an inverter-based resource. However, this does not mean that a project within our program is not included for those requirements. It is acceptable if a utility limits the actual response of the project to within the typical connection requirements. However, the project must demonstrate to the program that all technologies have the capabilities to meet the requirements of a synchronous generator for the minimum services, even if restricted in operation. Next, after identifying the key grid services and their specific capabilities as defined in grid codes or standards, the applicant must indicate how each requirement is met by the chosen project technologies. Each requirement should be proven met with supporting evidence such as data sheets, testing results, standard certifications, utility confirmation of capabilities, or confirmation by technology vendors. For example, a product may have a specific standard certification, which can be used to confirm active power control capabilities are present to meet primary frequency response requirements. Requirements which restrict an otherwise eligible program technology class should be identified with a justification for consideration. Finally, after identifying all key grid service sections, indicating how your project meets those with the chosen technologies, the applicant must include a verification plan which confirms the capabilities have been reviewed and are accurate, signed by a professional party or with third-party endorsement, such as a technology vendor. So that summarizes, one slide, there you go, thanks. So that summarizes the grid service requirements for emerging and established technologies. And now we will discuss the grid service requirements and templates specific to grid modernization projects. For grid modernization, a wider suite of services and values might be provided by eligible projects. We recognize from the prior Smart Grid program that grid modernization projects can be very diverse in terms of function and technology. All projects with a grid modernization component must speak to the grid modernization portion of the application template, section T 5.2. This includes utility-led grid modernization projects under the grid modernization stream and private-led grid modernization projects. A key requirement for grid mod projects stated in the applicant guide, section 5.2, is that all grid mod projects, regardless of funding stream, must be integrated into utility operational processes to ensure desired outcomes are achieved and available services are used. This requirement ensures that supported projects contribute value to the general electricity system and are not just benefiting the private project owner. Examples which could satisfy this requirement might include being a project owned or operated by utility or system operator, potentially a direct service contract or planned cooperation with an applicable utility or system operator to use those services, or plans to participate in a recognized utility service program, or provide ancillary services, such as providing demand response, peak load reduction, reserve provision, etc. In terms of the grid modernization template, the first step of completing the grid modernization grid service template is identifying grid service impacts within the impact categories provided in the template. These categories include improved asset utilization and increased efficiency, which may include reduced operational costs, increased reliability and resiliency, and finally, increased system flexibility and renewable energy penetration. A short explanation is necessary for each of these impact categories to describe how the project actually delivers on each applicable area. Next, once identifying the high-level grid service impact categories, direct outputs and outcomes are to be identified for the specific services and values. The difference between outputs and outcomes are shared here, and we will include a sample in the next slide. The template provided to successful registrants also includes examples of outputs and outcomes for several projects. Lastly, once identifying the direct outputs and outcomes, the applicant must describe how these services from the project will actually be integrated into electricity system operational processes. So in this slide, we include an example of what a completed grid modernization grid service template might look like, specifically for the direct outputs and outcomes. Note that in addition to this, each applicable impact category would have a brief description describing how the project delivers on these categories, and the application would include a description of how the project and services will be integrated into electricity system operational processes. In the example of improved asset utilization and increased efficiency, this sample project of a virtual power plant has a direct output, reduces curtailment of renewable energy, enables demand response provision, and enables peak load reduction. The outcome or results delivered are reduced losses in the system, increased revenues from reduced curtailment, savings from asset deferral, and reduced spinning reserve needs. Similar outputs and outcomes are provided for the impact category of increased system flexibility and renewable energy penetration as well. So now we'll quickly walk through the sample template that we provide with the application package. So so here we have the this template T5 is provided as part of the application package to successful registrants of the program. T5.1 is specific to those minimum grid services defined for established and emerging technologies, including, as mentioned, fast frequency response or inertial, primary frequency response, secondary frequency response, or automatic generation control, and reactive power and voltage control. To complete this section satisfactorily for the program, we described the process earlier, but the process again is identify for each of those 4 minimum grid services, the specific grid code requirements and text that describes those capabilities. For each of those capabilities, providing confirmation via external documentation that those capabilities are achieved by the selected technology. And then finally, providing verification, whether that be through a professional endorsement or third-party support, potentially by utility or by a technology vendor. Then if you can scroll down to the grid modernization section. Again, this section was shown in the prior slide for a completed project, but each grid modernization applicable project will need to complete this section, T5.2 of the application, specifying the direct outputs, outcomes, how the project will actually deliver on those outputs and outcomes, and a description of how those services will be used by utilities to deliver on those outcomes. So that is the template. We can go back to the slide deck now. And the next slide. So this concludes the planned grid services workshop content. Please note that in addition to this grid services workshop, we have held or are planning to hold the following additional targeted workshops. Information for workshop registration is available on the program webpage. and the recordings of these workshops, including today's, will be available after each session. One further note is that we are currently working on updating the applicant guide to be more clear in terms of the specific grid service requirements. I think we understand that the initial applicant guide was somewhat broad in the sense of what grid services could entail, but the updated applicant guide will be reflective of the presentation today in terms of the specific minimum grid service requirements, as well as the grid modernization components. And now we have the last half an hour of today's webinar for any or questions or feedback that you would like to discuss today. Thank you.